recording of SLO review. This is the 21st of April in the year 2017. What if we have a ball that gets thrown straight up, or a pair of keys, or a golf ball, or anything else? A chicken, I don't care. No, actually that'd be a bad example. If we want to know how far up this thing goes, what do we have to look for? If we know it's VI, let's say it has a VI of 5.0 meters per second. Is it easy to figure out how far up the thing goes? Yeah, because you know its acceleration. So we have its, how do we know the point at which it stops? VF goes to 0. So we have VI, we have VF, we have acceleration, and we want delta Y. If we had an initial velocity of 5.0 meters per second, VF is 0, acceleration is 9.81 meters per second squared. See, I'm trying that thing they do, and it's negative, and delta Y is what we want. We can do this. So we need VF, VI, A, and delta Y in this case. So VF squared equals VI squared plus 2A delta Y. Solving for delta Y, VF squared minus VI squared divided by 2A equals delta Y. Does this look like crazy easy to you now at this point? You look at this and you go, why did I ever even think that this was not the stupidest thing I had ever seen? So negative 5.0 meters per second, the whole lot squared, times 2 times, we're going to say that's a negative 9.81 meters per second squared, because of course our acceleration is downward. I know! Well, it's the same reaction, honestly, that people have when they get to physics after chemistry, and through chemistry they're like, oh my gosh, this is challenging. And they get to, they're like, oh my gosh, chemistry was so easy. Oh yeah, everything's easy looking back, you know. And 18-month-olds think like, oh my gosh, walking is so easy. Why didn't I do that when I was like 3 months old? Because we don't. Or something, maybe they think that, I don't know. Maybe they just think, ooh, food. It's pretty much what my daughter seems to have thought. Okay, so what do we get? We get 19.62 meters. It's crazy high. 5 meters per second is a pretty robust velocity for an object thrown upward. That's really sailing. Okay, questions? Comments? Okay, that's easy. Whoops. Okay, no. 1.27 meters per second. Let's try that. That's a little bit more reasonable. I thought 19.6 sounded crazy, but I thought, well, trust the math, Moser. Trust the math if you do it right. Okay. Yeah, that's better. If we have some object that's going from rest, and we know its rate of acceleration, and we want to know how long it takes to get to some final velocity, what would you use? Oh, gee, that looks like a likely candidate. Do you want me to? Yeah, if you want to know how long it takes for this object to be moving at 25 meters per second, could you do that? This is like a car ad. 0 to 25 in... Not, yeah, 9 meters per second. So VF minus VI divided by A equals delta T. 25 in 2.7 seconds. Well, 25 meters per second is highway speed. Was it 30 Gesundheit, or nearing highway speed? We can do the conversion. 2.7 7, and actually it would just be 3 meters per second if you look at sig figs, or equals delta t. Okay, here, let's do the conversion, because Annie doesn't believe me. What is delta x? So, do you remember what connects those two axes? What is that? Time. Time is the bridge between the two axes. So, if we have an initial, if we know our delta y, let's say delta y equals 3 meters, and it has a VI of 1.5 meters, how far out does it land? Well, if we do our variables on the two axes, oops. We know that delta y is, what, negative 1.5 meters. Acceleration all on the y. Oh, yes, it is. Jeez Louise. 9.81 meters per second squared, and of course we'll treat that as a negative once we get into the problem. Delta t ends up being our bridge. And we have this, 1.5 meters. We know that acceleration is 0, and we're looking for delta x. Delta t will be our bridge.
Monday and then take that slow Tuesday. Like over this stuff, because
I suppose we could.
I don't like when I'm looking at this right now. I think I know what I'm doing, but it's one of those things where you need to have the test in front of you to be able to make sure that you've got it. Yeah.
Okay. Yeah, I can do a FIP quiz. Yeah.
Unless you'd rather just print them out and give them this week.
Yeah, maybe that's just a review over this weekend.
Yeah, I'd rather like that.
Okay.
Then we can come in and talk about it on Monday. Monday's a double.
Monday's a double period. Tuesday's not. And I was hoping to not eat up too much more of your time because I really want to get into the circuits. Here's what I can do. Can I give you a sort of a take-home FIP? And if you have a chance to look it over, you get to look it over. Maybe they're going to disappear SLOs. Maybe and I think most of you got zeros on the first one. So if you list your variables and draw a picture, I give you some points.
What was the highest score?
I think 5 points out of like 70 on the pre-test. Yeah. I mean, the nice thing for me about the physics is it's stuff you've never had before. It's not like there's recall information here. You've not done projectile motion problems. You've not, so it's pretty easy to get very low scores on the beginning, which, then woohoo, look at me, I taught you stuff. We didn't just, eat buffalo chicken dip all year. Annie's dream physics class.
One teacher gave us a fill out, and at the beginning here, and it was just like a basic type English, and so it was easy if you just did it. So I got a high score to begin with. I got like a high B or a low A, and at the end of the year, the first gave us all the answers, and then we took it, and everyone got like 100%, and she gave us all bonus points based on how much we grew. But I already had a good score, so I got like 2 bonus points, and everyone else got like 20 bonus points.
What grade was that?
Last year.
Huh.
Yeah.
Why do I take this seriously? Resistor looks like. Oh, here's one. We're going to tell you what we're going to do.
I found a cool video.
Okay, with standing waves?
Yeah.
There are some awesome standing wave videos. This is, when we used to do physics of sound, this comes in with sound. I mean, this is basically what happens in a guitar string, is you're looking at the standing wave that's created, and you can figure out based on the speed of sound what note is being played. We don't do the sound unit anymore because it's not really in the standards, and when I look at what you need to do when you go off to high school or college physics, rather, Physics of sound is typically like a separate standalone course that only music majors take. I got to take it, and the class I was in was an even split between music majors and physics people picking up a physics elective. Yeah, you would love it. And there were all kinds of things that the music people were like, oh, well, that's a minor fifth. Huh? No idea. But it's all mathematical. Those fifths and thirds and sevenths and all those chords that I have no idea what they're talking about, those are all mathematical ratio relationships based on frequency. Whoa! Suffice to say, everybody was surprised by something and confounded by something. The music people, for the most part, were confounded by the math. I was confounded by the musical terminology. So, anyway. But, yeah, you would fit right in. Well, as belonging to both worlds, you know, those of you who are math, science people, and music people, get into a class like that and run with it. Okay.